Welcome to my presentation. In this presentation, we shall try to find the area of the triangle using geometry methods. And in our example 2, we have used determinants to find the area of the triangle. So in here, we are trying to follow up with whatever we did in example 2, and then show you that the other way to find the area of the triangle is also a way to find the area of the triangle. So the three vertices of the triangle are given to us as follows: the -1, 2, and then the second point was 2, 2, and then the third point was -2, 4. And if those are the 3 points given to us, when it is not a straight angle, when it is not a one of the triangles which we know, we need to then figure out a way to find the area of the triangle. From geometry, we know that area of any triangle, which could be like that, or which could be like that, or which could be like that. Area of any of those triangles can be found by this formula: S times S minus A times S minus B times S minus C, and we want to take the square root of all of that. So the area of the triangle is equal to the square root of S is the semi-perimeter. A, B, and C are the sides of the triangle. This could be side A, this could be side B, this could be side C. This could be A, that could be B, or that could be C. Or this could be A, that could be B, and that could be C. So S is the semi-perimeter. How do we find the perimeter? When we start from a point on the triangle and then walk along the triangle, outside of the triangle, and then come back to the same point, that is what is called the perimeter. Semi is 1/2 of that, 1/2 of the perimeter, A plus B plus C. We do not know the values of A, B, and C in here, so therefore we're going to find out what the values of A, B, and C are going to be. To do that, let us draw the graph of this, and then plot these 3 points on this graph sheet and see how we can do that. Okay, so this is let's put some points on this graph sheet: 1, 2, 3, and then this is -1, -2, and -3, and then we'll call this as 1, 2, 3, and 4. 3 and 4. The first point is -1, 2. -1 on the negative x-axis and 2 units on the positive y-axis. So this point here is -1, 2. The second point is 2, 2. 2 units on the positive x-axis, and then from there we're going to rise 2 units onto the positive y-axis. So that is the point. So therefore this is 2, 2. And then the third point we have is -2 and 4. -2 on the negative x-axis and 4 on the positive y-axis. So this point here is -2, 4. And now we'll join these 3 points. When we join these 3 points, let me join it like that. And once we have these 3 points, this is now a matter of finding the sides. If we call this as side A, and if we call this as side B, and if we call this as side C, and for our convenience, let's call that as that. Or we can also write this as okay, let us call these corners as this corner as A, this corner as B, and this corner as C. We know from geometry that the distance between 2 points can be found as follows, isn't it? Distance AB we can find that out as the square root of x2 minus x1, x2 minus x1 raised to the power of 2 plus y2 minus y1. We will use this distance formula to find the length of line segment AB. Okay, so when we do that, this is what we're going to have. So x2 in this case is going to be equal to x2 in this case is going to be equal to negative 1 minus of x1 is negative 2, this whole thing raised to the power of 2, plus y2 is 2, and then minus y1 is 4, this whole thing is raised to the power of 2, and then we take a square root of all of that, and when we simplify this math, this is going to be the square root of negative 1 plus 2, the whole thing raised to the power of 2, plus 2 minus 4 will be negative 2 raised to the power of 2. And when we simplify that, we're going to get negative 1 plus 2 will be 1 raised to the power of 2, plus negative 2 raised to the power of 2 will be 4. Negative 1 raised to the power of 2, we could have simplified this some more here right away. So this is going to be 1 raised to the power of 2 is going to be 1. Therefore, when we simplify that, that value is going to be equal to square root of 5. So therefore, the length of line segment AB is going to be equal to square root of 5. Similarly, we can find the value of the line segment, the distance between points B and C, and we'll call that distance BC. We'll use the same formula to find out the distance this time. BC is going to be equal to the square root of BC. x2 will be 2 minus x1 will be negative 1, this whole thing raised to the power of 2, plus y2 is 2 and y1 is 2, this whole thing raised to the power of 2, right? So this is going to be the square root of 2 minus of minus 1 will be 3, 2 plus 1 will be 3, 3 raised to the power of 2 will be 9, plus 2 minus 2 is 0, raised to the power of 2 will be 0. So therefore this is going to be square root of 9, and that's going to be equal to 3. So the distance BC is going to be equal to 3. And now we want to find the distance between AC. And how do we do that? The distance AC, we can find that as follows. That's going to be the square root of x2 minus x1. x2 minus x1. 2 minus of minus 2, this whole thing raised to the power of 2, plus y2, which is 2, minus 4, this whole thing raised to the power of 2. And when we simplify the math here, this is going to be square root of 2 plus 2 will be 4, 4 to the power of 2 will be 16, 4 times 4 is 16, right? Plus 2 minus 4 will be negative 2, negative 2 raised to the power of 2 will be positive 4. So therefore, we can write this as equal to square root of 20. Square root of 20 we can write as 4 times 5. And since 4 is a perfect square, we can write this one as 2 square root of 5. Therefore, the distance AC is going to be equal to 2 square root of 5. So we got all the three sides of the triangle, and now we can apply it in, plug it into the formula. We can find the semi-perimeter as follows. If we were to come back here and then plug it into this formula, the value of S is going to be equal to 1/2 of a was square root of 5, and then plus b was 3, and c was 2 square root of 5, isn't it? And therefore when we simplify this, the value we're going to get is 2 square root of 5 plus 1 square root of 5 is going to be 3 square root of 5 plus 3 divided by 2, and this is the value of s for us. We will use this and apply it into this formula. I'm going to write here, and the formula for area, we're going to plug it into the formula of the area, and therefore as we said, the area of the triangle, of any triangle, is going to be equal to s times s minus a times s minus b times s minus c. And when we plug these numbers in here, this is how it's going to look like. 3 plus 3 square root of 5 divided by 2, that is the value of s, times 3 plus 3 square root of 5 divided by 2 minus the value of a is 3, and then 3 plus 3 square root of 5 divided by 2, and the value of b is 2 square root of 5, like that, and then times 3 plus 3 square root of 5 divided by 2 minus square root of 5. We got all the values, and then all of this is under the square root symbol. And now we will simplify this and see what we get. This is going to be 3 plus 3 square root of 5 divided by 2 times, and when we simplify this, this is going to be the common denominator here is going to be 2. Therefore 3 plus 3 square root of 5 minus 3, like that, and then the next one is the common denominator is 2. 3 plus 3 square root of 5 minus 4 square root of 5, and then the third one is the common denominator here is 2. We have 3 plus 3 square root of 5 minus 2 square root of 5, and all of this under the radical term. And when we simplify this, this is going to be 3 plus 3 square root of 5 divided by 2, and then when we simplify this, it is going to be 3 minus 3, these cancel out, leaving us with 3 square root of 5 divided by 2. So here this should be a 6. Let me just go back here and then change that. This should be negative 6, and therefore this is not going to cancel out. In fact, it is going to simplify as follows. This is going to simplify as follows. This is going to be 3 minus 6 will be negative 3 plus 3 square root of 5 divided by 2, and then here we have 3 plus 3 square root of 5 minus 4 square root of 5 will be, this will be 3 minus 4 square root of 5, because those are similar terms, we are combining them, divided by 2, and then we have 3 square root of 5 minus 2 square root of 5 will be 1 square root of 5, therefore just square root of 5 divided by 2, and therefore this is what we have, and we need to simplify this. And now, as we know that the special forms of polynomial, that if we have a plus b times a minus b, we can write this one as a squared minus b squared. So therefore here we see that we have a 3 plus square root of 5 divided by 2 times negative 3 plus 3 square root of 5 divided by 2. We can write that as in the form of special forms of polynomial as follows, isn't it? In here this should be 3 minus minus square root of 5. Yeah, and therefore, yeah, this part here I'm going to write, we'll combine these two in the special forms of polynomial and then write this one out as follows. This is going to be 3 plus, I can also write it in this manner, negative 3 raised to the power of 2, negative 3 raised to the power of 2, or let me write it in this manner. I want to write this one as 3 square root of 5 raised to the power of 2 minus 3 raised to the power of 2, right, divided by 4, and then times, I'm going to combine these two in the special forms of polynomial, and therefore when I do that, this is how it's going to come out. 3 squared minus square root of 5 squared divided by 4, and all of this is under the radical term. So now, as we can see here, 3 square root of 5, the whole thing raised to the power of 5, we can write as 9 times 5 minus 9 divided by 4 times 9 minus 5 divided by 4. All of this under the radical term. When we simplify this some more, this is going to be 9 times 5 is 45 minus 9 times 9 minus 5 is 4, and then this whole thing divided by 4 times 4 is 16. Okay, 45 minus 9 is 36 times 4 divided by 16. Okay, now when we simplify that some more, 36 I can write as 9 times 4, and then I leave the 4 in the top there, and then in the bottom I can write this one as 4 times 4. So in here, as long as we have similar terms in the numerator and denominator, we can cancel them out. The 4, 4, 4 and 4 cancels out, leaving us with square root of 9. The square root of 9 is a perfect square, which is 3 squared, and therefore whenever we find the square root of a perfect square, it's going to come out as its base term, so therefore the value is equal to 3. This seemed to be a long procedure, but nevertheless this is the check we have to find the area of a triangle. You see how simple it is to find the area of the triangle using the formula, using the determinants formula, and we can also find we can also check our answer using the known methods this way. But this is one other way to find the area of the triangle. So in my next presentation, we shall look at some more applications using determinants.